Hi, my name is Ross Henzel. I work for DQE Communications. DQE Communications is the premier service provider for telecommunications that has 3,000 miles of fiber all throughout Western PA. We're headquartered in Western Pennsylvania, actually in Pittsburgh, and we focus on data, one of the reasons why we've been growing phenomenally in the past few years. We provide solutions in Ethernet, Internet, and private, secure connections to the cloud, such as Amazon and Microsoft Azure. I'd like to introduce MSA, Management Science Associates. Management Science Associates is full of curious, analytical, creative people who love putting data to work. I'd like to introduce Kevin Whitfield and Bob Liekar. Thank you.
Thank you. Hi, I'm Kevin Whitfield from Management Science Associates, my colleague Bob Liekar. We're here to talk today about advanced retail analytics using Apache Kafka and Hadoop, and the problems that we've faced and how we've overcome these challenges. Let's see if we can get this going. There we go. So I'm going to try to quickly get through the soft skills of this piece of the business problem that we faced and the technology problems that we faced, and quickly turn it over to Bob, who's going to get more into the technical solution that we've put together. We deal with, mainly our customer base is manufacturers of consumer packaged goods, and they're trying very desperately to reach the individual consumer these days. It's no longer enough to get their product into the store, and prior to that it was just moving their product through the chain. They now want to get right to the individual consumer so that they can target their marketing and their promotions to the individual. So we've had our customers come to us and say, you've got to help us get to this point. It's not enough anymore to say, yeah, we're getting the product into your area. The consumer wants to know, when I go to the store, it's going to be there. And when I go to the store, I have what I think the price should be, and I want to make sure that the product that as a manufacturer, the product that I'm putting out there meets that consumer's needs. So we're providing an analytical platform, advanced analytics on top of consumer POS scan data. When you're scanning product at the cash register, that's the data that we're now incorporating into our solution set. So to solve this problem, what were the technology problems that come along with that? We, of course, need to put together a cost-effective solution. This isn't going to work if it's going to cost tons and tons of money. Excuse me. So cost performant, it has to be well-performing, fast. Our customers want to get to their insights quickly. They don't want to be spending even 5 minutes waiting for a query to run, waiting for a report to pop up. They want to get to this stuff very quickly. So for us, putting the solution together, we want a multi-tenant solution, which means that this isn't going to be a solution for customer A and a separate solution for customer B and a separate solution for customer C. The solution set all has to build from one platform with the ability to give each customer the solution that they want, the customizations that they want on top of this one platform. So therefore, security is very, very big in what we have to provide. If we're combining these data sources into customer delivery, the customer significance of their data has to be protected from other customers. So of course, security is very big. Again, performance is very important. This is a lot of information, as we all know what big data is. This is a lot of information. Digging through that data quickly is a real challenge. So we've used the Hadoop area to get us into these things, which includes replication, disaster tolerance, all of these things to get to combining all these data sources together. So what did we do? We said, okay, there's the problem. We're going to put together an analytic platform, provide advanced analytics on top of this data so that our customers can get to the insights that they need. But why would the retailer supply this data to the manufacturer? This is very valuable data. So we've worked with our customers, the manufacturers, and help to build partnerships with the retailers so that together it's a win-win situation for both of them. Together, the manufacturer is now getting better understanding of their trade marketing programs, and the retailer, of course, is hopefully getting more customers into the store and a benefit of the trade marketing program, so that the manufacturer is helping them to help the manufacturer. And again, the business problem has to accommodate for, we know what data sets we have today, we know what data sets we've worked with traditionally, and we're now working with this retail takeaway data, and there's, of course, we all know there's just so many different diverse data sets out there today that we do know about, and there are many data sources that we're just learning about, and there are many data sources that are yet to come. Not all of that data today has the value that would integrate into this package, but we need to be prepared for when new data sources are available or other data sources are found, such as environmental data mixing in with this data, and other various forms of consumer data, weather data. All of this has an impact on sales, and that's what our customers are interested in. So our technology solution, we wanted to build first and foremost an advanced analytics platform to, again, provide the capability for these customers to very quickly dig through this information, get to the insights that they want. It has to be flexible. Visualization is huge. Again, it's an awful lot of information, and in order for the customer to really get to that value of the information, find quickly what they're looking for, visualization is just such a huge assistance in that. We know that data architecture and a flexible data architecture is very, very important to the solution, again, because we know what we know about the data sources today. We don't know what we don't know about the data sources yet to come, and we want a flexible data architecture that will allow us to consume that information relatively easily and quickly. We want a platform that's going to bring that on quickly, going to provide for the customer that is really most interested in basic reports. I'm just looking at these basic things, all the way up to the customers that are interested in very, very detailed analytics, diving deep into the data, and all of that is coming from the same platform, and customized as well as just consumer-oriented. We want to componentize. We want to be able to plug and play different technologies as they come along. And then the data ingestion process is extremely critical as well. That has to very quickly consume this information as it comes to us, because one, we want to provide the insights out quickly, but two, we need to make sure that any anomalies in the data that are discovered very quickly, because the supplier of this data doesn't have a lot of opportunity to adjust that information. 3 days from now, they're not going back and changing the data. It's 2 weeks from now is just out of the question. So we very quickly want to get these insights back to the supplier so that the data is that much more valuable out to the customer. In addition to the advanced analytics capabilities, we certainly have to have a data management platform underneath of that. And so we've put together an event streaming solution on a Hadoop platform. Again, we need to ingest large amounts of data quickly. We've designed this in what we call a design to replace mode, which is we know that technology changes. We all know that. Every day something new is on the marketplace. Every day there's something more interesting to work with. And so we want to, in our componentization of the system, we want to make sure that we have the ability to essentially plug and play. A new technology comes along, a new method comes along, things are going to be replaced. If we don't design to replace, it's no longer a world where we can design something that's going to live exactly as it is for 20 years. Things are going to change very, very frequently. Master data management in this system is very, very critical. There's automation that has to occur. We need to be able to match items very quickly, and we need to be able to master new products, new ideas, new information very quickly. Again, we've got to provide this insight back to our customer and back to the data suppliers as rapidly as possible, and it has to be pretty accurate. This is audit level data. This is information that customers are making payments off of, making critical business decisions off of, critical programming decisions off of, marketing decisions. So accuracy is extremely important. And we all know velocity of data and the big data V's and all of those things and the rapid changing of data, but the velocity also belongs to the software. Things particularly in the open source world change very, very rapidly. And so what we've adopted is an attitude of when we're looking at the technologies and we're doing a POC, we want to fail fast. And so what we do is we instead of taking a 3-month effort to bake off these 3 different products and see who comes out at the end as a winner, we do our best to try to really hone in on, we think this one's pretty good. Let's stand it up. Let's work on this. Let's get through this as quickly as we can. If it's going to fail, let's fail now so that we can make our adjustments now to go back and figure out what's the next step to take. And again, it's a rapidly changing world, so it's very important to take on this fail-fast opportunity. Very rarely do you have the opportunity anymore to put things out there for 3 or 4 weeks. Hybrid cloud, on-premise, all cloud, those are all parts of our solution, all parts of what people are doing today, and very important to developing these type of technologies. And there's 2 other points I want to make, and then I'll turn it over to Bob. One is resources are very, very difficult to find. This is an emerging area. It's certainly well placed. People are doing great things with this, great production things with this, but the resources are very, very difficult to find. And secondly, not every shiny tool out there is a tool you want to put in your belt. There's a lot of shiny products, a lot of really cool things out there. You have to be diligent in choosing the right ones. That it needs to have support, it needs to have sustainability, it needs to have capabilities. There's a lot of interoperability that goes on, and those things are very, very critical. With that, we'll get much more into the technology end of it.
Thanks, Kevin. Good afternoon. I'm Bob Liekar. I'm a director in the IMS division at MSA. I'm responsible for development in the big data environment and data science. So consequently, my part of the presentation is going to be very geeky. I'm going to get into a lot of the technology, the specific technologies we've used, and really more importantly, how we've used it and a lot of the practical lessons we've learned. So this is meant to be a buzzword-free, hype-free discussion of what it really means to put to stand up a system in a big data environment. The system we've developed is a production system. It wasn't a prototype, it's not a trial, this is a production system which is at the core of our business for a paying customer. So I said I'm going to give you a buzzword-free presentation. I'm looking at my slide and it has the buzzwords all over it. So let me go through this quickly. A key part of our system is Spark and Kafka. Spark is a development execution engine or framework for processing data in high volumes at high speed. I'm sure you've heard of it. And Kafka is basically a queuing or messaging system. So this part in our architecture, Spark and Kafka, if you look at their place in the architecture, are a small part of it, but a really crucial part of it. They're the engine which takes in the billions of records and processes them high speed and turns into usable data. Polyglot persistent architecture. A lot of buzzwords. What does it mean? It means we have a heterogeneous database architecture, which means we use different types of databases for different purposes. And you think too, someone might spin that and say, well, we do that because you use different databases for different purposes because you're using best of breed for those different purposes. In reality, I won't say forced to that, but you are led in that direction up because you're picking best of breed, because many of these big data tools and databases are so special purpose and are tuned for special purposes that you can't generalize these for general purposes like you do with Oracle. So the Oracle is very mature, has lots of components, and you can, it's meant to be the database used. But in this environment, we use HBase and Hive and Postgres, and a lot of flat files in this brave new world. So that architecture, each of those pieces or formats were picked for special purposes depending on how we were going to access it. Data structures and process design to stand up for me quickly. Again, this is good design in general, but really in this environment we did not want to make a monolithic application which is built for a purpose. There is not an application. This is a collection of components which are meant to, each piece is meant to be stood up quickly, be flexible, scaled up, modified quickly, and then thrown away. Not just the programs, but actually the databases and the data stores. The data stores, the databases are meant, in the traditional world, you put so much effort into database architecture and designing it to make sure it does what you need and it supports your applications. Here it's like, we have a purpose, we need something for a special purpose, spin it up, throw it out there, use as long as you need it, and it'll change continuously and be thrown away. Might stay a long time, it might stay for, disappear in a few days. Delivery to many different changing endpoints. Endpoints, just use cases. Again, it's not a monolithic application where the data is coming through going to what is the application. There are many different uses of many different kinds. By different kinds, I mean there are some traditional dashboards, BI reporting, and that sort of thing, but also we're supporting data mining and predictive modeling and things like that, machine learning applications being developed by data scientists. So this data is coming through and being used by many, many different types of applications, and they require different data structures and different velocity of the data. The sort of data structure you'd spin up for a data scientist is different from what you develop for a data feed, a customer, or a payment system. So we'll talk about some of this specifically. This picture, there's a lot on there. Don't try and read it all. Just the details of the system as we have it now. And if you did look at it closely, and it actually should look pretty familiar to you, because although we're using new technologies and new techniques, in the end, a lot of what we're doing is a lot of the things you do in the traditional world need to be done here. On the left, you get files from outside, you bring them in, put them to your ETL system, they end up in a warehouse. Then the warehouse goes into the next step where you apply security and semantics for delivery for particular customer purposes. At the surface, a very traditional sort of data architecture. And people, they give the new terms like the polyglot architecture and the terms that make it sound like this is a new way of processing, new way of thinking, and there is a lot of that in there. But they tend to lose sight of there's many traditional things that you really also need to stay on top of, because we weren't doing a POC or just playing around trying to supply a data scientist to play around with models. This is a production system that is used for advanced analytics, as well as actually our customer uses this to cut checks to their vendors. And a very important part, I'll get some more detail. On the left, the ETL process, they call it data wrangling. So they call it data wrangling. It's not just a new buzzword, a new term. I think it's a really important distinction, because the data scientists, they do wrangling, but really it's kind of, they don't understand the importance of it, the complexity of it, and for me to make it productionized. They are taking in and they're playing with it, building their models, but for this sort of system, we needed to build an industrial strength application which never fails, never quits, and protects the integrity and the validity of our data. And those are things which the data scientists and the people doing the data mining don't appreciate, that this is a production system. Ingestion. Let me go right from those details to the ingestion part of it. Again, I thought it was going to be very technical. I think the point was to introduce you and give you some insight into the tools we're using and what the use means in the practical world. So on the left, we're getting typical data warehouse, lots of sources, internal, external. We have internal data warehouses that we're using as feeds. We're getting data from our customers. We have this is a POS system, so it deals with retailers. We're getting tens of thousands of files in for, I think right now we're getting data for about 80,000 stores. But the goal is that the system will be processing data for 200,000 stores when it's done. So all the data comes in, and obviously at volume and quickly, because we deliver these systems, the results on a weekly basis, sometimes on a daily basis. So when we talk about ingesting data for 200,000 stores, we need to turn around in a day and make it available to our customers for their analytics and their reports and our own analytics. The key part of this, you can see in the Spark stream in the middle, that's a really key part of our architecture. In this world, there's so many technologies that come and go so fast. I mean, it's always been true in the technology world, right? But in this world, it's literally every few months, something's coming up and things go by the wayside. So you have to be really judicious in your choice of tools. or reach the, sorry, I've run out of time already. I'd be happy to stick around. I mean, there's, the rest of the slides are going into detail, and some of the things I've introduced. I will be more than happy to stick around afterwards to answer questions. I think the slide presentation also is available from the Tech Council, or I can make it available. Again, I apologize for running out of time, and again, afterwards I'll be around for a while. Be happy to go into the details of these technologies and their use and application, and then lessons we've learned. Yep, thank you.